The countdown to 2024, which is shaping out to be the year of moon landings, has begun in the next 12 months. As many as 12 missions could fly past or land on the moon, the most in a single year. In January alone, 3 missions are scheduled. Japan's slim mission plans to make its maiden lunar landing on January 19th. If successful, it will be only the 5th country after Russia, the United States, China, and India which landed on the lunar surface in 2023 too. Businesses are competing to be the first to make a commercial landing on a celestial body. Intuitive Machines and Astrobotic are part of NASA's Commercial Lunar Payload Services (CLPS) program and symbolize the U.S. commercial space sector's rising ambitions. There are 3 key overlapping reasons for the moon's strong interest. First, the cost of access to space continues to diminish as the cost of launch vehicles and spacecraft systems falls. This opens up the market to new entrants because moon missions can now cost less than used $100 million, as evidenced by India's 2023 Chandrayaan 3 mission. The development of commercial capability, such as Intuitive Machines and Astrobotic, is especially interesting since it will enable solely commercial missions or the delivery of payloads from nations who do not have their own lunar landing capabilities. Indeed, Astrobotic's mission includes miniature rovers developed by Mexico for the country's maiden lunar trip. Second, there is a great deal of scientific and commercial interest in lunar exploration and resources. The moon most certainly has mineable water resources that can be exploited for in-space refueling, and astronauts support many of the missions in 2024 are either directly or indirectly concerned with the search for water. Third, the resurgence of geopolitical competition has resulted in substantial financing for civil space initiatives. Many newcomers to space research are quickly adopting competing views of international cooperation in space, such as the United States' Artemis Accords and the China International Lunar Research Station. Both China and the United States have planned flagship missions in 2024, highlighting the competitiveness. China aims to launch the Chang'e 6 mission, which will return the first scientific samples from the lunar far side in May, following the successful return of samples from the Chang'e. A 5 mission, the Chang'e. A 6 mission will demonstrate China's ability to operate throughout the entire lunar surface. A successful flight will keep Japan on schedule to meet its objective of landing Tiona by 2030. Notably, equipment from Pakistan, Italy, France, and Sweden will be aboard the lander. The United States intends to launch the Artemis 2 mission, which will fly by the moon with a human crew in November. The 4 astronauts on EMIS 2, including 1 Canadian, will be the first to leave Earth orbit since the 1970s. This mission will set the framework for a crewed return to the lunar surface in 2026 or 2027, with ongoing missions expected by the end of the decade and the creation of a lunar surface base in the early 2030s. Several smaller flybys, orbiters, and landers are planted, and in addition to these larger missions, China is launching a relay satellite to the South Pole to enable future missions. A Japanese mission is contemplating a flyby on its way to an asteroid, while iPace, a private business, is attempting to land again after a near miss in 2023. NASA's Viper rover, which is on its way to the lunar South Pole, is perhaps the most interesting of the other missions. The moon's South Pole has permanently shaded regions which never get sunlight and are predicted to hold significant amounts of volatiles, such as water. The rover is supposed to look for these volatiles, crossing into shadowy areas to collect samples. However, because Viper is solar-powered, it will only be able to operate and investigate those locations for a short period of time. Nonetheless, it is feasible that it may establish that there is enough ice to sustain mining activities, so unleashing the possibility for lunar development. This decade, these missions will not all be successful. Even landing on the moon is a technological problem, as demonstrated by Russia's Luna 25 lander's loss in 2023. The first major barrier to gaining access to the lunar surface is landing with so many commercial and national landing attempts. In 2024, even 2 or 3 successful landings would be a tremendous technological achievement. Successful landings as well as failure lessons will demonstrate that newbie countries and private industry can reach the moon. This year's culmination of so many missions underscores the last 5 years of heightened emphasis on the moon. Despite these high-profile trips, the most significant advancements for lunar development in 2024 are anticipated to take place on Earth. Multiple launch vehicles capable of lunar delivery are set to fly for the first time after years of research. Astrobotic's January mission will be launched on Eula's Vulcan. Europe's Ariane 6 is set to launch later this year, and Blue Origin's New Glenn may even reach orbit. All 3 will broaden access to the moon. The most visible, however, is SpaceX's Starship, which will launch into space in November 2023 and 2024. An orbital launch attempt is almost certain because Starship is NASA's human lander. For Artemis III, its success in 2024 will determine whether a human landing in the 2020s is feasible. Geopolitical improvement is also expected to continue in the coming year. In 2023, India signed the Artemis Accords, signaling a significant shift in lunar geopolitics and a triumph for U.S. diplomacy. In 2024, more countries are likely to join the Artemis Accords or the International Lunar Research Station. Finally, the next 12 months may indicate that lunar exploration has gained irreversible pace. If many landers are successful, the contemporary lunar era will begin in 2024.